Hi students, good morning everyone. So what's up guys? What's going on? Am I audible and visible to you? And guys, please mark your attendance and tell me the topic that we were discussing in the previous class. Hi Shillong, can you hear me? Okay. Or dear, I have to check that once. Give me a minute. Dear, first three chapters are coming in your examination. First three chapters. But I have to confirm it. But I have to confirm it whether it is from 11th or 12th. Okay. Yeah, 1, 2, 3. First three chapters. But I have to confirm whether these chapters are from class 11th syllabus or 12th syllabus. Definitely, dear. I'll confirm it by the afternoon. Okay. After your class, within 1 hour, I'll confirm it to you that what syllabus will be there. Okay. So guys, by the way, how are you feeling? Is all good? And please share the topic that we were discussing in the previous class. What happened, Shillong? Why are you surviving? Live your beautiful life. I know this is a kind of survival till the examination. But even meanwhile, you can enjoy your time. Yes, dear. If you dream big, then you have to work hard behind that. Okay? So guys, yeah. So guys, any question for me from the last class? Any query, any doubt that you want to ask me? Any student who has got any question or query for me? You can ask me right now. If not, then we can start. Okay, I guess Vesper theory we were discussing in the previous class, and we have prepared a table of the Vesper theory, and we have to learn that how to determine the shape of a molecule. Is it true? Do we have to discuss the shapes, that how to draw the shapes of the different molecules? Or do we have discussed that? Shillong, kindly confirm. Okay. Okay, cool. So guys, the topic is the shape draw. Guys, you can refer your table that we have drawn in the last class. Okay. Today we have to learn that how to use that table. Okay. Guys, please do not copy anything. Just look at the screen. First of all, make sure that you are clear with the concept, because these kind of questions will be definitely asked in the examinations. Okay. And these are very simple questions that we can solve in, we can say, few seconds as well. Okay. So guys, just look at your screen, try to understand the concept and use the table. Okay. Guys, I'll start with the CH4. And meanwhile, guys, I need one person on the system so that he or she can reply to me by the consent of all. Okay. So guys, let's start with the CH4. Now, first of all, we have to calculate n by 2. Guys, can you please tell me that what is the central atom in CH4? What is the central atom in CH4? Need not to copy anything, just look at the screen. Central atom in CH4. Yes, definitely carbon is the central atom. So guys, first of all, we have to write the number of valence electron of the central atom. We know that carbon contains the 4 valence electron, plus how many other atoms are there other than central atom? How many other atoms other than central atom? Yes, definitely 4. Divided by 2. You will get 4. What I have done, that I have used the number of valence electron of the central atom, and after that I have just added the number of other elements, or we can say other atoms present over there. After that we will get a number which is 4. So guys, in the table you have to just refer and check out how we can draw or how we can arrange the atoms when n by 2 is equals to 4. Guys, you can refer your table. Here I am drawing it for you. So just look at this. Carbon will be placed at the center. Then we have to make 4 bonds like this. This is our first case, that we have to make the 4 bonds. Okay. We have got the central atom. We have prepared the 4 bonds, because n by 2 represents that we have to draw the 4 bonds, and this is the real arrangement, that how we can put the 4 bonds. Now, just put the atoms on these bonds, because we have got the 4 atoms and the 4 bonds, so I'll put all those atoms over there. So guys, this is the case where no lone pair of electrons, only bond pairs are present. Bond pair means only bonds are present over there. That's why this shape is tetrahedral. This shape is tetrahedral. Guys, you can remember one thing. The natural angle in tetrahedral is 109 degree 27 minutes. Okay. Sometimes you will find that it is 109 degree 28 minutes. So guys, are not much difference between 27 and 28. Okay. You can be comfortable with both. Okay. So you can learn this bond angle, that whenever you will talk about the tetrahedral, bond angle will be 109 degree 27 minutes. Okay. Now I'm taking another example. Let's talk about the ammonia. So guys, first of all we have to calculate the n by 2. Now again, first of all we have to check out the central atom, which is nitrogen. So we have to write the valence electron of the nitrogen, which are 5, plus add the number of atoms other than the central atom, which are 3 over here. So 5 plus 3 will be 8, divided by 2 will comes out to be 4. So guys, again we have got the 4. So what we have to do? Put the central atom, make the 4 bonds that you can see from your table, that how we can draw the 4 bonds. Now guys, the point is here we have only 3 surrounding elements, or we can say we have got only 3 surrounding atoms, okay, that we can put over these bonds. So I'll put these atoms over here. Now there is one bond where I cannot put any atom, because I have to place only 3 atoms that I have already placed over there. That's why guys, this will become by default lone pair. This one will become by default lone pair. Okay, are you getting this? This by default become the lone pair. And guys, one important thing that you have to remember, guys, I'll cover up in the bond angles again, but here I'm giving you the brief idea that how lone pair of electron affects the bond angle. You can simply remember presence of one lone pair reduces bond angle nearly by 2 degrees. Guys, this is not hard and fast. This is not hard and fast that it will be reduced by 2 degree exactly. It will be nearly 2 degrees. Okay. So guys, please answer me one question, that if natural bond angle is 109 degree 28 minutes, guys, you have to remember for the geometry where n by 2 is equals to 4, bond angle will be 109 degree. Now one lone pair is present over there. So due to presence of one lone pair, what should be the new bond angle? What should be the new bond angle? What? Guys, bond angle is reduced, not increased. And you have crosses the limit. Okay, 107 degree. Yes, exactly, guys. And the interesting thing is that the actual bond angle is 107 degree, or we can say 107.8 degrees. This is the actual bond angle. Okay. If I subtract 2 from 109 degree 28 minutes, I'll get the 107 degree 27 minutes. Okay. But that is not exact. So exact bond angle is 107 degree 28 minutes. Not sorry, 107.8 degrees. Okay. Next. Let's talk about H2O. Again, we have to calculate n by 2. Here, central atom is oxygen, whose number of valence electrons are 6 plus 2 upon 2, which is again 4. So guys, oxygen will be at the center. So make your arrangement when n by 2 is 4. This is your arrangement. But the problem is I can put only 2 atoms over there. So here I have put those 2 atoms. Now rest 2 will become the lone pairs. And the name of this shape is pent, or we can say angular. Can anyone please predict what can be the bond angle on the basis of that trick? What can be the possible bond angle? Yeah, 105 degree it should be, but actual bond angle is 104.5 degrees. Okay, so that was just a trick, and we are actually very near after learning that trick that this should be the answer of that question. Okay, so guys, first of all, please clear me, confirm me once that are you clear with the first three examples? Are you clear with the first three examples? Okay, I can see few hands. Okay. Okay, guys. Okay, guys, let's learn one more thing along with it. Hybridization. Guys, do you remember that I have also prepared a column of the hybridization? Guys, hybridization depends on the value of n by 2 only. So you can check out over there where I have written the 4. Guys, look at this. Look at this. I'm telling you a trick. See, n by 2. If it is 2, you have to just write the sp. You have to remember it, because it can use one orbital of the s and one orbital of the p. That's why it is the sp. If it is 3, we know that p can have the 3 orbital, but s can have only 1. That's why I'll write s and then 2p, which is sp2. For the 4, it will become sp3. For the 5, guys, we have already used all s, all p's, because p can maximum have the 3 orbitals. Now the next orbital should comes out to be d. After that, sp3, d2. After that, sp3, d3. Okay, so guys, I'm using it. Look at this. Here, if I look at the n by 2, which is 4, on the basis of this one, hybridization should be sp3. Okay, again, here n by 2 is 4, so hybridization would be sp3. Here, if I look at this, hybridization again will be what? sp3. Okay, so guys, are you getting that how I am calculating the hybridization? Any confusion or doubt in this one? Clear? Confusion? Do I need to repeat it again? Okay. So guys, let's take few other example as well. For example, I say okay, let's move on to the next one. Yeah, next shape. See, for n by 2 is equals to 5. Okay. Guys, just look at your screen. After that, I'll give you time to copy it. Guys, if you remember that for n by 2, we have drawn shape like this. Okay. Guys, these bonds with the green dashes are known as the axial bonds. And the bonds with the purple dash are your equatorial bonds. Guys, first of all, you have to learn one thing, that in this case, you have to remember axial bonds are filled first. Then equatorial. You have to remember that you have to first put the atoms on the axial bonds, and after that you will put the atoms on the equatorial bonds. Okay, let me take an example. First of all, let's talk about the PCl5. Calculate the n by 2. Phosphorus is the central atom who has got the 5 valence electron plus 5 other elements. So answer would be 5. So if I talk about the hybridization, so guys, you can simply check out and you can say it is sp3d. Okay. Now, let's draw its shape. Cl, 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 Cl. And the name of the shape is trigonal bipyramidal. Okay. Now, guys, relax. I'll give you time to copy it. Don't worry. Okay. Just make sure that every example is clear to you, because after that I'll give you few questions. Okay, that you have to solve it. So just learn the meaning of these shapes and understand the concept. Now, guys, look at this. SF4. Calculate the n by 2. Sulfur has got the 6 valence electron plus 4 upon 2. It will comes out to be 5. Again, hybridization will be sp3. Okay, sp3d. Now, do your work. Put the sulfur here and look at this. So, guys, first of all, I'll put the atoms on the axial bonds, and after that equilateral bonds. So I have put 2 atoms over here, and this one will become lone pair. And guys, one interesting thing, that if you want to imagine the shape, say standard shape you have to learn. For example, tetrahedral, trigonal, bipyramidal, or planar, or octahedral you have to learn. Other than that, what can you do? If you want to learn the shape, guys, just hide the lone pair of electron, and after the hiding, just look at the shape and tell me, is it look like seesaw? Hide the lone pair. See, I'm removing it. Guys, look at this. Can you imagine that? Is it look like seesaw? Okay. So guys, in this manner, you can just look at the example and you can have a guess that this could be the answer. So this is the seesaw. Okay. Now, next one. Let's talk about I3 minus. Okay. Let's calculate the n by 2. Guys, understand this example, very important and very nice example, this one. See, you have got 3 iodines. Obviously, out of 3 iodines, one will be definitely at the center. So, I'll use the valence electron of the center. So, that will be 7. Iodine is a halogen. So, out of 3, one is present at the center. Obviously, we will left with the 2. Okay. So, I'll use 2 here. Guys, you can look at the negative charge over there. Negative means gain of the electrons. So, I'll add 1 by 2. It will again comes out to be 5. Hybridization again will be what? sp3d. Okay. So, guys, just put your electron pairs and after that put the atoms. See, put the axial bonds first, and see, we can put only 3 atoms over there. So after that, just put the lone pair of electrons. Just put the lone pair of electrons. Guys, hide the lone pair of electrons and please tell me, is it look like linear? Hide the lone pair of electron. Is it look like linear? Linear means all the atoms are in the same line. So guys, the shape is linear. Okay. Now, important thing. This is for oxygen. This is the case of the oxygen. Okay. Guys, look at this. In calculation of n by 2, if oxygen is not central atom, then do not count it for n by 2 calculation. Guys, let me clear it to you. Let's understand the meaning of this one. I am saying draw the shape of the SO3. Let's calculate the n by 2. We can look at this and we can say that sulfur should be the central atom. And guys, we have to consider the lone pair of electrons of the central atom. That is true. That you have to always do. Plus, you can see the oxygens. Guys, oxygens here are not the central atom. They are actually the central atoms. Sorry, they are actually the surrounding atoms. You have to remember that if oxygen is the surrounding atom, then you won't add it. Okay? You will use oxygen only and only in case of where it is used as a central atom. Else, you will never use it. So, I'll put 0 over here by 2. So, answer will be 3. Okay? So, for the 3, the arrangement of bonds like this, and you can put oxygens here. Okay? And this is your planar. Okay? Guys, you have to remember this one. For example, if I say SO2. Okay? So, if I calculate the n by 2 again, I'll get 6 plus 0 by 2, which is 3. So, again, I'll put the sulfur over here. 3 bonds. I'll put 2 oxygens here. And 1 will become lone pair. And this shape is known as your bent shape. Guys, please confirm me quickly. Any doubt or query for me till now up to these examples? Any example which is not clear to you? Okay. Next. Look at this. Case where n by 2 equal to 6. Okay. You can check out the arrangement of atoms. It is like this. So guys, look at this. The bonds in the green are known as the axial bonds. The bond in the black are known as the planar. Okay. Or we can say the square positions. Because these 4 are in the same plane, that's why they are known as the either planar or the square positions. Okay. So guys, first of all, these are your axial bonds, or you can see the axial positions. And the bond in the black are the square positions. Okay. Look at this. These are the square positions. Okay. So guys, here the rule says that square positions are filled first, then axial positions. Okay. So guys, let's take another example. Let's say suppose we have got XeFO. Okay. So guys, we can check out the XeFO. Let's calculate the n by 2. Xenon has got the 8 electrons. Fluorine has 4 because it is the central. It is not the central atom. It is the surrounding atom. So answer will come out to be 6. So for the 6, hybridization would be sp3d2. Guys, I'll discuss the hybridization separately, that what exact meaning of the hybridization, but this is just a formula to calculate the hybridization. Okay? Because in the examination. Okay. Huh. Can I start this example? Can I start with this example? See, let's understand this. This is the last example that we have to understand. Okay, after that, you can copy that one. And if I got any query, I'll entertain your query. Okay, guys, look at this. This is xenon. Put the atoms. So guys, as we know that we have to fill the square positions first. Let's fill the square positions first. And after that, these will become the lone pairs. And this shape is known as your square planar shape. Square planar. That's it. Guys, I'm giving you time to copy it. I'll start with the first slide. Copy quickly and just respond it to me. Okay. And if any example is not clear to you, you can please ask me. Please, you can start now. This is the first example. And don't worry, if you have got any query or doubt, you can ask me. I'll clear it to you. Okay. Guys, draw the shapes carefully. Okay. And after drawing, you can confirm. And guys, the shape or the name of this shape is pyramidal. You can hide the lone pair and you can look at this. It will look like a pyramid. Okay, let's move on. Do this one. This is n by 2 equal to 5. Case where n by 2 equals to 5. Guys, do it carefully that the 3 bonds are the equilateral bonds which are marked with the purple dash, and the 2 bonds which are marked with the green dash are the axial bonds. Okay. And you can remember one thing, that axial bonds are larger than equatorial bonds. Okay. Remember this one as well, that axial bonds are longer than equatorial bonds. Equatorial bonds. Done? Okay, let's move on. Attempt these examples as well. Okay, copy. Do this one. Okay. Guys, one more thing you can add over here, that you have to put the negative sign as well. So you can put it like this. You can put it like this. This is the way to represent the negative or the positive sign. Please do this one as well. Put this negative sign like this. Now, this one. Copy this one. Next, wait. Okay, yeah. Do this one. Copy this one. Okay guys, so just go through the ones just go through the ones from all these shapes. Okay, I'm just revising it. Quick revision of this one. After that, I'll give you questions. Guys, just look at the screen. Okay, just look at the screen. Then we will start. I'll give you a few questions based on this one. The first example was CH4. What I have told you to do, that you have to calculate the n by 2, and for the calculation of n by 2, first of all, check out the central atom and use the valence electron of the central atom. And after that, check out the surrounding atoms here, which is 4. So that's why I have put 4 over here. Okay. So guys, this is the way how we can calculate the n by 2. Okay. Use valence electron of the central atom and add, and after that add the total number of atoms other than the central atom. Okay. So this 4 signifies that around the carbon there can be only 4 bonds. Okay. And we know that when we have got the 4 bonds, we can place those 4 bonds like this. This is the arrangement. Yes, you can place randomly anywhere because it won't affect the geometry. Okay. Ultimately, the before position of the lone pair, all the bonds are at the equal distance and the equal bond angle. See, the bond angle is right now, which is 109 degree 28 minutes. Okay. So it is 109 degree 28 minutes for the every other bonds. Okay. Now, look at this. Let me clear it to you. Guys, look at this. I can draw this shape even like this. I can put hydrogen here and I can put lone pair over here. Even this one is definitely a right geometry, guys. This one is also the right shape. But the problem is this is on the paper difficult to imagine. Now it doesn't. No, dear, I'm telling you, look at the screen. Dear, look at this. If you imagine this one, it is not looking like pyramidal right now. But guys, it is pyramidal actually. See, these are the 3D shapes. Look at this. If I use it like this, and if I draw this bond like this, okay, even this one will also result into the pyramid. Okay. Guys, you can put anywhere, any atom, the shape will remain same. No changes from the shape. Okay. It is actually very difficult to imagine on the paper. That's why we choose that position where we can imagine very easily. That's the only reason. Okay. So don't worry for that. But yeah, try to use in the manner where I have discussed with you. Okay. Are you clear with this one? Guys, any problem? Is it clear to everyone what I was saying? Confirm once. Okay, yeah, that's what I was telling you. Okay, good. So guys, let's move on to the next one. You can look at the H2O over here. Okay. Guys, look at the position, the bond angle, or we can say the bonds in the H2O. See, it is not necessary that you will draw H2O like this. If I draw H2O like this, even this one is also the correct geometry. This one is also the correct geometry. But guys, again, on the paper, it will be now difficult to imagine. Okay. So that's why we imagine that at the top we will put the lone pairs, and at the bottom positions we will use the atoms. Okay. So that it becomes little bit clear to us. Okay. Now, remember for the case of n by 2, first of all you have to fill the axial bonds. This is the first note. You have to first axial bonds, first after that equilateral bonds. After that, this is the case of the oxygen. Remember guys, in case of oxygen, if it is not central atom, you won't use it in the n/2 calculations. Remember it. Okay. Next, for n/2 equal to 6, you have to remember guys that square positions will be filled first, and after that you will start filling the axial positions. Okay. The position in the green are the axial position, the position in the black are the square positions. And this is the example of this one. Guys, quickly tell me, is there any confusion or doubt regarding any shape, any question? Confirm me once. Confirm me once, after that I'll give you question. And remember, this is very important topic. Okay, so guys, this is the question for you. I'm giving a few examples. You have to draw the shapes, you have to tell me the hybridization and name of the shape as well. Definitely guys, you can use your table. Okay, I would suggest that how will you use the table? That let's say suppose you have got n/2 equal to 4. Okay, so guys, you have to just look at the table and check that how I can draw the 4 positions when n/2 equal to 4. And after that, just check out the number of atoms over there and put at those positions. If you won't get the sufficient atoms, then the remaining bonds will become the lone pairs. Okay, and after removing the lone pairs, hide the lone pairs, try to imagine the shape, check out the table, and just look at the answer. Okay, that whether you are close enough or not. Okay. This is how you have to use the lone pair. The table. Okay. And guys, yes, after attempting these questions, you have to just tell me that you have attempted all the questions. After that, I'll start solving it. Okay. You can start, guys. You have to write the shape as well. The question with the purple, do it carefully. Okay. Attempt these questions, guys. Attempt these questions. You have to draw the shapes, calculate the hybridization, and after attempting that, just tell me and I'll start solving it. Then you have to check how many of you has got the all right answers. Those who are busy in the talking with or with some other stuffs, guys, please don't do that. Attempt the questions. The student on the second bench on my left hand side. Dear, what are you talking about? The student on the second bench on my left hand side. On the first bench of my left hand side. Dear, are you doing these questions? Guys, use the table. and do these questions carefully. You can take your time, relax, but be careful. If anyone has still some doubt, you can ask me. Over, guys. Don't stuck at any example. Left that if you are not much clear regarding that. I'm giving you 2 more minutes to solve these questions. After that, we'll start. Done? Okay, guys, so can we start? Or you need some more time? Okay, so let's begin. First example is NH4 positive. N by 2. Nitrogen is the central atom. Use valence electrons plus 4 minus 1 because there was the positive charge. It will comes out to be 4. And we know that what is the correct way to place 4 atoms. And this one will be your tetrahedral. If I talk about the hybridization, it will be sp3. Okay? Number 2, BeCl2. Calculate the n by 2. Beryllium is 2 valence electrons plus 2 upon 2. It will be 2. Hybridization would comes out to be sp. And if we talk about the shape, BeCl2 will be this one. This is your linear. Okay. Next, PCl3. Phosphorus 5 plus 3 by 2 equals to 4. So finally it will look like this. This is a pyramidal. Again it is sp3. Next, SF4. Sulfur 6, fluorine 4 by 2. I think we have discussed SF4. SF4 is already discussed, which is seesaw. Okay. Then XeF2. N by 2. 8 plus 2 by 2 will be equals to 5. So this is actually this one. This is your linear. Hybridization will be sp3d. Next was XeF4. Calculate the n by 2. Guys, here xenon is the central atom, so it will be 8 plus 4 upon 2 equals to 6. Remember, I have told you that do not use oxygen if it is not the central atom, so I haven't used it. So you can look at the shape. This is your oxygen, 4 fluorines and 1 lone pair. This is your square pyramidal. This is your square pyramidal. Okay? Next is NO2. Guys, we can't draw the NO2 by the use of this theory because it will contain the odd number of electrons. So we can't draw it. Let's move on to the ClF3. Chlorine 7, fluorine 3 by 2 will be equals to 5. So ClF3 will actually look like this. Or you can draw it like this. Guys, just hide the lone pairs and look at this. It actually the T shape. Okay? It actually looks like the T shape. What about the last one? IF7. The only known example of sp3d3 till now. N by 2. 7 plus 7 by 2 will be equals to 7. So this is actually look like this. Pentagonal bipyramidal. IF7. Hybridization will be sp3d3. Those students who has got all answers correct can write their name, and those who wants to copy anything can please tell me that which page is left that haven't got copied by you. All got correct. Are you writing it with the, okay, except NO2. Is all class got the all right answers? All the student has got the right answers? Make a count again, because I know that all the students haven't got the right answer. Reason being because few students, not few, the student who I can watch even haven't solved these questions, all the questions. So I think so that all the students haven't got the right answer. So make a count and don't tell a lie. Anyone wants to copy anything? Any shape? So you have improvised the statement. Very good. Okay, fine. So guys, this is all about your Vesper theory. We have learned about the drawing shapes and how to calculate the hybridization. Guys, I have told you that this is your very important year. So those who are doing some other stuffs, kindly don't do that. Be in the class, okay, and try to solve the questions. Okay guys, so that's it. Let's take a break of 5 minutes. Okay, I'll see you after the 5 minutes with a new theory. Welcome back. Are you back from the break? Hi everyone. Guys, am I audible to you? Hey Shillong, are you there guys? Okay. Now what is the total attendance right now? Or any question or any query for me? Anything that you want to ask me? Please, anything if you want to ask me? Okay. So guys, let's begin with the new topic. Can you mark the attendance right now? What is the total number of students right now? Okay. So guys, let's begin with the new topic, which is hybridization. Ready guys with the hybridization? We have already learned a trick that how we can determine the hybridization of any molecule, okay? For the solving the questions, I'll use that trick always, okay? Here we have to discuss that what hybridization is, how it occurs, okay? Why do we need the hybridization, okay? So guys, in the valence bond theory, we have discussed that how bonds can be formed. It says that for the formation of bonds, we need atomic orbitals containing the electrons and they must overlap with each other for the formation of a chemical bond, okay? After that, we have learned about the shape, that how we can draw the shapes by the help of Vesper theory, okay? So guys, even with the VBT theory, we are not still clear with few examples where we can get the exact concept that how bonds can be formed, or we can say that, for example, if I talk about the CH4 guys, all 4 bonds are equal, okay, and they have the same bond length. Guys, about this one, it is not much clear in the valence bond theory, okay, that how carbon, a single atom, will form the 4 bonds, okay. In the VBT, we have learned that that how between 2 atoms a bond can be formed, okay. But after that, with the multiple bonds, or if we talk about the molecules, where how multiple bonds can be formed over there, it is not much clear over there, okay. So that is clear in the case of hybridization, okay. If I talk about PCl5, PCl5 has got the 2 types of bonds. One is the axial bonds and the second is the equatorial bonds. Guys, again, there is not much clarification in the previous theories that how axial bonds are different from the equatorial bonds, okay. How axial bonds will be different from the equatorial bonds. So all those some phenomena which are left over there will be covered in the hybridization. If I talk about the question in the examination will be asked from you that how or what will be the hybridization of that molecule, and that I have already discussed with you with the help of a trick. I'll use that trick in few more examples as well, okay. So guys, first of all, let's write the hybridization, okay. You can copy it along with me, its important points, okay. It is the intermixing of atomic orbitals of slightly different energies so as to redistribute the energies and shape forming new orbitals having same shape and energy are called hybrid orbital. Copy, please. Copied? Okay. Characteristics. Guys, copy along with me. Hybridization is a mixing of orbitals, not electrons. Therefore, in hybridization, fully filled, half filled, and empty orbital may take part. And guys, this is the shape of the hybrid orbital. One second. This is the shape of the hybrid orbital. The bigger lobe is generally considered as a positive, whereas the smaller lobe is generally considered as a negative. And guys, this is your structure of hybrid orbital. How it will look like. Hybrid orbital. Copy it. Let's move on. Number of hybrid orbitals formed are equal to number of atomic orbital intermixed. Next, the hybrid orbital are differentiated as sp, sp2, sp3, etc. Number 4, order of repulsion. I think I have already discussed about it once, that lone pair is maximum, then lone pair bond pair, and minimum will be between bond pair and bond pair. Copy and confirm. Okay, next. The bond is formed along the bigger lobe present in hybrid orbital. Okay. Guys, these are few important characteristics that we should remember to understand the meaning of the hybridization much clearly. Okay. Just copy it and then let's continue. Over. Lobe means this one. 1 second. We have seen such structure now. So look at this. This is the lobe. This is the bigger lobe, and this is your smaller lobe. Have you got that? The section in the yellow represents the bigger lobe, and the section in the what? Yeah, pink is the smaller lobe. Okay, cool. So guys, is there anyone who is feeling sleepy? And who is just waiting to end the class? Oh wow, I have seen a hand. Can we continue? Guys, this is a quite important concept, so you have to just focused, okay, while understanding this. Okay. So guys, let's begin with the concept. Okay, just look at the screen. Do not copy anything. Okay, need not to copy anything. I'll give you time to copy it. Just look at the screen. First of all, let's discuss about the sp hybridization. Guys, I'm taking an example of BeCl2. Okay, guys, if I talk you about the BeCl2, definitely beryllium is your central atom. Okay, so before you proceeding, just pick your central atom, which is beryllium. Its atomic number is 4. Okay, right? Have electronic configuration which is 1s2 and 2s2. One s two and 2s2. Okay, so guys, look at this. This is the ground state configuration. This is your ground state configuration, where I can represent it like this. 2 electrons and 1 p as well over there in the ground state. Guys, can anyone please tell me, in beryllium, what is the valence shell? Or what is the valence orbital in the beryllium? Can anyone please tell me? Valence orbital. Oh yeah, very good. 2s is the valence orbital. Okay. So guys, remember one thing. Always the electrons, or we can say the orbitals of the valence will participate. Okay. So if I say the excited state, how to write the excited state? In case of excited state, you can see this is 2s and this is your 2p. Okay, so 2s and 2p both are the valence orbitals. So guys, while writing the excited state, make sure that every orbital, or we can say in the every orbital, you have to just write the half-filled orbital electrons. Okay, if there is any pairing. Okay, what I'm saying that if pairing is there, make them unpaired while writing the excited state. So guys, I can see that 2s I can write with the help of 1 electron, and 1 electron of the 2s will jump to the next one to make it again unpaired. Okay, I'm telling it again that while writing the excited state, if there is paired electrons, make them unpaired, send the paired electron to the next available vacant orbital. So for the 2s, the next available vacant orbital was the 2p. That's why I have shifted 1 electron from 2s to the 2p. Is it clear to everyone? How to write the excited state? Clear, or do I need to take another example? Because I won't repeat it again and again. Okay, I can see one hand. Can I see the hands of those students who has got clear this one? Confirm once. Okay. Let's continue. Guys, please answer me one more question. That in writing the excited state, means in excited state, how many orbitals are there which contains the unpaired electrons? How many orbitals are there which contains the unpaired electron in excited state? How many orbitals which contains the unpaired electron? Question is, in excited state, how many orbitals are showing the unpaired electron? Exactly 2. Guys, look at this. These two contains the unpaired electron. So guys, what actually I was trying to say, look at this, that one orbital of s will be used and one orbital of p will be used. Look at the box where unpaired electrons are present in the excited state. That's why we are saying it is a sp, because we will use one orbital of the s and one orbital of the p. That's why after intermixing of this one, the resulting configuration will be the sp configuration. Are you getting it? Because we have got only two orbitals during the intermixing process. That's why it is the sp. Any doubt about it? Okay, let's move on. Let's move on, guys. Look at this. You want to copy it first? Please copy it, then we'll move on. Please copy it. Confirm once after copying that. Done? Okay, let's move on. See. So guys, we have got two orbitals which will undergo the hybridization process. Okay. One is your 2s and one is from 2p. Let's suppose it is 2px. Okay. Because we will have three orbitals of the p, which is x, y, and z. I am taking the 2px. Okay. When they will overlap with each other, look at this. This is your s, this is your p. Whenever they will overlap with each other, after the intermixing, it will result into the hybrid orbitals. And we will get two hybrid orbitals. Two such orbitals. Okay. Now guys, I want to ask you one more question. See, these are again the kind of electron pairs. At what angle in the space I should place these so that the repulsion between them should be minimum? At what angle I should place these two orbitals, this is the internuclear axis, so as I'll get the minimum repulsion between them? What should be the angle? Means how can I place in the space these two orbitals to minimize the repulsion? Exactly. So guys, I'll start it. Look at the screen. See, I'll place these two orbitals. 1, 2. So guys, hybrid orbitals are placed in its correct position where they will get the minimum repulsion, and these hybrid orbitals are of beryllium. Now guys, the next important point, to make the further bonds between beryllium and the chlorine, remember you have to use the hybrid orbital of the central atom and the normal orbitals of the remaining, or we can say the surrounding atoms. I'm repeating that we have to use the normal orbitals. Normal orbitals means the orbitals which are outermost. So chlorine, can anyone please tell me what is the outermost orbital of the chlorine? What is the outermost orbital of the chlorine? I want to just know SPDF. What would be the outermost orbital of the chlorine? Yeah, this is 7 electrons in the outermost shell. I'm asking what is the orbital, S, P, D or F in case of chlorine? Guys, chlorine is present in the 17th group, which is a p block element. Therefore, the outermost orbital of the chlorine is the p. No dear, it's p, not d. Chlorine is the group 17 element, which is a p block element. So actually, chlorine uses its p orbital for the bond formation purposes. So guys, look at this. Just draw normal shape of chlorine. Look at this. These are chlorine. Now look at this. This is your BeCl2 and the bond angle is 180 degree and hybridization will be sp. Guys, kindly confirm once. And one more thing. This is positive, this is positive, this is negative, this is positive, positive, and then negative. Is BeCl2 clear to everyone? Any confusion or doubt? If not, you can please tell me. Guys, positive and negative are not the charges, these are the phases actually. Okay? These are the phases actually. So guys, let's move on to the next one. Let's talk about the BeCl3. I'll start with the boron, which is 5. Just look at the screen. 1s2, 2s2, 2p1. This is the ground state configuration. Now, I can draw it like this. Again the ground state configuration. I have to write the excited state configuration. So what will I do? I'll make the paired unpaired. I'll send this electron in this orbital. Okay. Now guys, you can see clearly this is your 2s and this is your 2p. Central atom will use 3 orbital for the bond formation. One is s and 2 from the p. That's why it is known as the sp2. Because 2 orbitals of p are being used over here, that's why it is known as the sp2 orbital. Sorry, sp2 hybridization. Okay. Now again, if I talk about this one, definitely there are 3 orbitals which will intermix. One is s and 2 is from the p. Okay. So we will get the 3 hybrid orbitals. So guys, can you please tell me that what should be the angle in space so that the 3 orbitals will get the minimum repulsion? What should be the position of those hybrid orbitals? First of all, copy it please. Just copy it. Done? Yeah, exactly. It is 120 degree. Okay. So guys, look at this. How you can draw it. First of all, let me draw it and after that I'll give you time to copy it. Just look at the screen that how to draw it. I'm drawing the 3 orbitals. These are the hybrid orbitals of the beryllium. Now, there was the BeCl3, so I'll use the outermost orbital of the chlorine. So look at this. One chlorine. Two chlorine and 3 chlorine. Guys, look at this. Chlorine, chlorine, and chlorine. And bond angle was 120 degrees. This is how we draw the BCl3. Clear? We can draw the phases as well. Positive, positive, negative, positive, positive, negative, positive, positive, negative. I'll tell you guys why are we writing this positive and negative and what is the significance of this positive and negative. Okay? Please copy it. Is it clear to everyone? Copy and confirm. Okay, let's move on. Check out CH4. Let's talk about the carbon, atomic number 6. This time you can copy along with me, okay? Hybridization, configurations 1s2, 2s2, 2p2 is your ground state. When I'll write the excited state, I'll make all the paired electrons unpaired. This is your excited state, okay? So we can see here one orbital of S and 3 from the P, Px plus Py plus Pz will results into sp3. That's why it is known as the sp3 hybridization. Okay. Trick you already knows about it. You have to just calculate the n by 2 and you will get the hybridization. Okay. Now let's draw it. And guys, for the sp3 means we will got the 4 hybrid orbitals. So when we will arrange these orbitals in the space, so when I'll put these orbitals at an angle of 109 degree 27 minutes or 28 minutes, I'll get the minimum repulsion. That's why the bond angle between them is 109 degree 28 minutes. Okay. Now look at this. How to draw it. First lobe, second lobe, third, fourth. Clear? This is how you can arrange the 4 orbitals. Look at this. This is the carbon. 1, 2, 3, 4. Put the 4 hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. And bond angle is 109 degree 27 minutes. Got it? draw it. And if you have any question, you're most welcome, guys. You're most welcome. If you have got any query. Is everyone had copied that? Okay, done. Before drawing the next shape, can anyone please tell me hybridization of SO4 2 minus? This is the question for you guys. Write the answer along with your name. If all have got the same answer, you can write the all. Calculate the hybridization. Or we can say determine the hybridization of SO4 2 minus. Need not to draw anything, guys. Just use the n/2 and tell me the answer. Okay, who has got this answer? Okay. Only one. What about others? Let's calculate it. Sulfur is the central atom. Use the valence electron. Plus oxygen is 0. Okay, sp3d2. Who has got this answer? Plus 2 upon 2. Okay. This is 4. For the 4, answer is sp3. So guys, answer would be sp3. Okay. I have told you that do not count the oxygens while determining the n/2 if it is not central atom. Those who has got the sp3d2, I think so they have definitely used the oxygens. Okay, so guys, that's all about it for today's session. Okay, kindly revise it again. Try to attempt the previous year's questions based on these particular theories. Okay, in the next class we will continue with the hybridization. Okay, so guys, if you've got any question or query, you can please send your questions, your queries on the WhatsApp groups, where I have added over there. Okay, so guys, see you next time. Till then, take care. Bye-bye. Have a good time. Please take care of yourself. Stay healthy. Bye-bye.